Hello student, welcome to our physics discussion, that is physics in a smart way. So in our last class, we have just started to discuss work, and our idea was that, and our conclusion was that work is basically energy, or energy remains in the form of work when it is getting transformed or when it is getting transferred from a body to other. So already we have got over that. Now we go to the formula of the work. That work, as our book say, that is the dot product or scalar product of force and displacement. Work is the scalar product of force and displacement. As I have written here, work is F dot S. If somebody elaborates that, if somebody opens up that, that is magnitude of the force into magnitude of the displacement into cos of the angle, and here the theta is the angle between the force and displacement. We know this red line, if we refer to the figure 1, the red line, it shows the so-called it is the line of displacement, and the force makes an angle theta with that. So we got or else if you draw the force here and draw the S here, we can clearly see angle between them is theta. That you can see in figure 3. Sorry, in figure 3, I have written it in a slightly different way. That is figure 3. It should be, let me correct it. That should be figure 3. Okay. So now coming back to the formula of work, because the basic formula of work is F dot S or Fs cos theta. We know the first way is to find out work. We now go through the number of different ways the student is able to think of work. If the force and displacement they are in ijk form, I cap, j cap, k cap, and I think by this time you are conversant on that. Ijk form, you can directly go for the dot product, or else we can use this formula, that value of the force, magnitude of the force into magnitude of the displacement into cosine of the angle between them. A student also can see it like this. That is number one way. A student also can see it like this. He or she can say work equal to, we know that is Fs cos theta. He or she can say that is F cos theta into S. And in place of F cos theta, he is writing F parallel. These two lines represent the parallel, F parallel into S. So here the meaning is to be that if somebody is to find the work, then it can be found out if we multiply with the displacement with the component or the value of the force component or the part of the force which is parallel to our displacement, which is parallel to the displacement, then the same thing would be giving us work. So here in number 2, I am repeating again, that is the displacement into the part of the force which is parallel to displacement, or component of the force which is parallel with the displacement. That I have written as F parallel. Here in the diagram, you can clearly see if you are aware on the component since the time of scalar and vector. If I take cos theta, then cos theta equal to F parallel by F, and F parallel will be equal to cos theta equal to F parallel by F. Sorry. Then cross multiplying, we can say that F parallel will be equal to how much? Will be equal to F cos theta. Okay, so thereby, if somebody uses the formula directly Fs cos theta, it's all right, no problem. Or else work can be visualized as the displacement pull into the part of the displacement which is parallel to it, which is F parallel. F parallel means part of the force part of the force which is parallel or along the displacement. The same idea can be extended also if somebody does it otherwise, that is, number 3, we can write, sorry, this is work, this is not force. We can write work as, we know basically that is F cos theta. That is F into your S cos theta. One can write like this. So that is F. F means the full force into the part of the displacement. This can be represented as part of the displacement which is parallel to the force. Now I am writing that as is parallel. You refer to figure 3. For this, you refer to figure 3. In figure 3, we know the force makes an angle theta. That angle, if I extend the force line, that angle will make an angle theta, which will make the same angle when you resolve the displacement into two components. One is S perpendicular, other is S parallel. S parallel means the component of the displacement which is parallel to the force. S parallel means component of the displacement which is parallel to the force, and S perpendicular means the component of the part of the displacement which is normal to the force. We don't require that. So thereby our work also can be written as F into S parallel because the formula simply suggests like that. So whether a student goes for Fs cos theta or takes S as full and part of the force which is parallel to displacement, or F full into part of the displacement as parallel to the force, the choice is him or her. In fact, the choice is not his or her. That should be judiciously selected looking at the difficulty of the issue. We should opt the way or the path of least resistance. We should opt the way or the path of the minimum effort that takes us to our conclusion or to the solution. Okay, thank you. Next class, we'll be considering a question to elaborate all those things, all those principles, and then we'll be trying to find out, we'll be trying to calculate how, or you'll be seeing how to calculate work or how to find out work in a practical way. The question is not very simple. Also, the question is not very difficult, but that will be helping us in going for these roundabout ways of finding the work in different cases. Okay, so thank you all for that.